So today is Decentralized Applications 101, or why the heck should I build a DApp, a DApp, whatever you want to call it. It's one of those things where no matter what I say, I'm going to be on the wrong side of history. Is it a GIF? Is it a GIF? Nobody knows. So hopefully they don't dig this up too soon. And so the default question of anybody peering into this space is basically, if you've gotten to the point of the word decentralized application or DApp or DApp, you're generally saying, what the heck is it and why should I build it? And if you get further than that, it's how do you actually do it? And there really aren't that many resources out there. It can be very hard to find information. Hopefully again, when this is dug up in many years, it'll be a different story. But right now, there is a black hole. There's a lot of stuff that's left over from last year's frothy boom, and it's not terribly helpful. It's very focused on how do you make as much money as quickly as possible. Throw some advisors up on your website, write a white paper, and it's like they're conflating blockchains with DApps with all sorts of other things, and it doesn't really make a lot of sense. And then the other half of things are super technical guides that tend to be, okay, well, so how it starts with the code and then it builds up, and there's not a lot of in between. So what I'm hoping to do today is kind of bridge some of those gaps, and we'll have some time at the end to address questions as well. I'm sure you guys will have plenty. Just quick background on me. So I work at Near Protocol, and basically what we're doing is building a fully sharded, scalable blockchain, and we're focused on usability and developer experience. And my background is in education, and I've previously run an education company in the online space and spent some time playing on Wall Street doing analytics and things like that. So this is pretty old hat for me, and I really like being a part of it. As far as today, so our roadmap basically looks like going to kind of start from the high level and work down. We're going to be talking a little bit about the high level of blockchain and decentralization and things like that. Hopefully won't spend all of the time there. And then moving more into the actual interaction of how do you touch DApps, how do you work with them, and then digging a little bit deeper and looking under the hood at how are the technical flows set up. So diving in, what is a decentralized app? So again, if you Google that, it comes up with some really strange stuff. And I mean, all you really need to do is you need to have the app itself distributed across a lot of nodes, whether those are people or whatever it is. The app needs to run in a distributed fashion. It needs to store its data in a distributed fashion. And basically there can't be a single point of failure, because otherwise it might be distributed but centralized. So the whole point of a decentralized app here is that there's no single point of failure. Things that are not requirements, you don't have to have an ICO, you don't even have to have a token. And you don't actually technically have to be open source, although that's something I'll talk about in the end. But whether or not you want to be open source, your code is running on other people's machines, and so you effectively are regardless. So in terms of terminology, we hear DApps, DApps, and smart contracts, all of that kind of conflated. Smart contracts are really a subset of what goes on in a DApp. And I'm going to use the word DApp. I don't want to have to qualify it every time and say DApp. So the DApp, the app, if you think about a web app, an app contains all sorts of things. There's the front end, there's the server side, there's the database, and you all kind of think of the whole thing as the app. And the same thing is true with a DApp, a decentralized app, right? The app contains so much more than just the part that touches the blockchain, and that's the smart contract. The smart contract is and we'll see this in a little bit more detail, but the smart contract is really just a portion of it. So it's very easy. Again, a lot of language that you'll probably find in materials will sort of conflate the two things, but DApp is much bigger. So the way I kind of want to do this is just start with Web 2, start with today, and just benchmark things on that, and then we can look at what's different in the decentralized world. And that way everybody's on the same page, and we have a good ground to start on. And so if you've worked with Web 2 apps or normal apps, as you can call them. It has a front end that lives in either a browser or on a mobile phone or something like that. Your front end basically sends requests to a server. That server talks to a database and stores data. And the server is owned by one person. The database is owned by one person or controlled by one person. Practically speaking, a lot of times these actually are made up of distributed systems. So the server's probably hosted on the cloud somewhere, which is a whole bunch of servers that are distributed. Your database in large companies like Facebook and things like that, it's super distributed and it's sharded into lots of little pieces. But in the end of the day, what actually matters is the fact that all of this is controlled by one person or one entity. So it's not, it might be distributed, but again, it's centralized. So centralization has a lot of advantages. There's a reason why we've done it this far and why it's worked out so well. You have full control over everything that's going on. We have a lot of experience building business models that are based on the current architecture. SaaS is an enormously impactful business model that's changed the entire world in the way that we operate software and off software. Cost. It's not that expensive to run a web app these days. We have speed. It's super fast. And another one that's maybe underappreciated until you start comparing it to the decentralized world is the speed of iteration is super high. Because again, you just push your code to the server, all of your server instances have all the same code, and the next request that comes in from some user somewhere is immediately going to be running your new code. That makes it so you can iterate your business, you can iterate your app very, very quickly in a centralized fashion. And of course, one of the things that we all kind of grind our teeth on is that moats are well understood from a business perspective as well. We know that if we own the data, we know how to monetize it, and we know how to prevent you from leaving the app because we're going to give you a better and better experience. Or, well, yeah, there are a lot of ways, obviously, of gating these apps, and I think we've all found them all. And some of the downsides are they tend to be a little bit more abstract. And so in some countries, in some places, in some people with some subgroups, these are very, very painful. For most of us, especially here in this room, these are probably a little bit more abstract. Censorship is a very real thing, though. Sometimes, so one of the core ways of censoring is if I run a platform, if I'm Facebook and you're building, and you're Zynga and you're building games and you're spamming my newsfeed, congratulations, you just built $1 billion business and I just kicked you off my platform, and that hurts a lot. Then there's also unintended censorship where, you kind of hear, you control the guns, you control anything. If they know where to send the people with guns or the people with lawyers or, the people with handcuffs, then they can make you do things. So, let's say hypothetically Facebook didn't want to give up their data. If the Department of Justice comes in and makes them, they're going to have to do that. And that's because they're a centralized company, and in order to operate in this country, they have to play by the law, and the law knows where to find them. So obviously hacking is something that everybody's familiar with, and the fact that the more data you centralize, the more it becomes a target, and frankly, the more it can become a liability for you as a company as well. So data is a double-edged sword, more and more so these days. Again, on one side you have machine learning and artificial intelligence advances that are kind of adding value to data, and on the other side you have increased instances of hacking and more consciousness around privacy, like Europe's GDPR and things like that are making data a liability, because once you do get hacked, it's starting to raise the penalty. And then finally, another one, of course, is the more data you have lying somewhere, the more valuable it is for anyone. And so if your company goes bankrupt, if your company wants to sell that data and monetize it, they can do that. And you might have, they might have started with the best of intentions, but you're now on your data is now on the auction block 5 years down the road, 10 years down the road, and you don't really know where that's going. So one of the core paradigms of people who are building these applications in today's world is basically hoarding data. It's always, up until now, it's been how much data can we get, how valuable can that data be, and we're all going to basically suck data out of the user and all their interactions and store it in our silos, and then exchange it with each other and use that to build shadow profiles for advertisers behind the scenes and things like that. And that's more or less the way that the web works right now, is everything that you do leaves this ripple effect of data, and everybody else is frantically vacuuming it up and paying other people for portions of it and things like that. So if we look at the difference on the decentralized side, so at the very, very high level architecturally, we still need a front end. We still need to put the app in a browser, on a mobile phone, whatever it is, right? You need to be able to interact with the app somehow, and that uses the same set of tools that you're used to in the normal world, which is HTML, CSS, and JavaScript. That also has to get served from somewhere. It has to find its way to you somehow, and generally we use conventional servers for that. So there's nothing too revolutionary about that. What's new about it is that the front end actually talks back to a blockchain instead of using a database, instead of using a centralized database. And that's basically via the smart contract. And we'll talk about the wallets as well. And it kind of goes via the wallet to the smart contract to the blockchain. And the smart contract is running on the blockchain. So I guess it's a little bit reversed. It's to the blockchain, which runs the smart contract. But architecturally speaking, the real difference I want to highlight is that the database is kind of out, and the smart contract talking to the blockchain is in. Oh, and then at the very bottom, you can see that one of the core benefits as well, or one of the core differences, is that data is generally being stored or worked with on behalf of the user and with permission from the user. So we'll take a look at that in the interactions. So just a quick thing to note, if you see a lot of blockchain diagrams, they're really bad. Like, they're wrong. You have a lot of diagrams that are sort of squares in a loop, which doesn't make a lot of sense. Some of them do forking, which makes sense a little bit. But they kind of get wrong the idea, like it kind of gives you the sense that there's some sort of centralized chain. And I think the most important mental model that you can have is that this is a distributed system with lots and lots of individual nodes that make it up. So each individual node is actually running the chain. Each individual node is running your smart contract. And that's really important because that's what gives us our decentralization. So diagrams are actually really powerful because that's what benchmarks your mental model, or at least it does for me. So it's good to have a good diagram. And I will say, our designer has not taken a look at this. So this is not, I'm not qualifying this as a good diagram, but at least it gives you that idea. So some of the advantages are, kind of the flips of the disadvantages on the centralized side. There's a lack of censorship. You also don't have the same platform risk that Facebook's going to kick your app off because your app kind of just runs out there. It's kind of you put it out there and then it's running on 100,000 or 1,000 or 100 or however many nodes, and there's really nobody else who can mess with it on your behalf. And of course, everybody can see the code that's running because your code has to run on all of these machines. So somebody's actually seeing the code. It's not hidden. It's not hidden behind a server. So you can actually verify what's going on. So there are problems. This is not me standing on my soapbox and boosting decentralization. Decentralization comes with very real costs, and a lot of people don't really talk too much about this stuff, but it is expensive. So on the right, you can see that it's sort of a conventional thing that they say is, you can be better, faster, and cheaper, and you can pick any two of the, or cheaper, and you can pick any two of those. And decentralization is actually almost the opposite. It's you can be better, you can't be cheaper, you can't be faster, because almost definitionally, when you're decentralizing something across many nodes, each one of those nodes is effectively running a server of its own. So at a minimum, if you're running 100 nodes, it's going to cost you 100 times as much as running on a server, that same amount of compute, if we're thinking apples to apples. So blockchain is not cheaper. Blockchain is also not faster. I mean, if running something on an Amazon AWS server, or even just your laptop running a web server, a simple web server, is going to be infinitely faster. Okay, exaggeration. Engineers will take issue with that, but I mean, it's going to be orders of magnitude faster than anything on blockchain, because blockchain, it has to not only run the code, but then it also has to talk to all the other nodes and agree that everybody ran the same code and everybody got the same result from that code, right? So all of that takes time. So whereas something will be single-digit milliseconds to run on a centralized server system, in the blockchain it could be multiple seconds. I mean, in Ethereum it takes 14 seconds, or is it 14? It's 10, whatever it is. It's on the order of 14 seconds. Bitcoin on the order of 10 minutes. And platforms, we're beginning to see an asymptotic push downwards, but there's just a minimum amount of stuff that you need to do on a blockchain to get everybody to agree. So it's never going to get to the single-digit milliseconds. At best, we're going to be getting into sub-second. A few other things that are a little bit less clear, I guess. One is just the service side. So if nobody really owns this app, so that's the other thing about this is when you're a developer and you kind of put your app out there and it's running on the chain, and you don't really control it anymore technically, because it's running out there. Like you could get hit by a bus and it'll still keep running. But the problem is how do you add a service layer on top of that? This is something that a lot of people have struggled with, because there's a lot of narratives around remove the middleman. If everything's on the blockchain, then we don't have to pay Airbnb to list our houses. But the problem is what goes wrong when somebody comes to your house and they trash it. You want services. What goes wrong? What happens if you lost your password? So services are actually a valuable thing that we haven't really figured out how to tie those back to a decentralized app, because who provides the services and how do they get compensated for that? And then privacy is the other thing. Again, blockchain doesn't solve privacy. It doesn't solve privacy. It doesn't solve the right to be forgotten and things like that. I mean, your data lives out there, and it's an immutable record, and it's an append-only database. So it's back there somewhere. So these aren't resolved issues, despite what you may have heard and what might be written out there. So these are definitely open questions. Thus far, the real question is it worth the trade-off, right? Like, what's worth me spending more money and taking more time? And thus far, we found money, definitely. So Bitcoin is still the killer app. Store of value right now. Originally, it started as a transactional thing. Now it's more of a store of value thing. You have someone like Ripple doing more of a transactional thing on optimizing for cross-border transactions and kind of a medium of exchange for remittances and things like that, trying to replace Swift. Those are really the killer apps right now. But then you also have things like what can't exist without blockchain. Well, you have black markets. I mean, that's pretty clear. We had Silk Road. And we have a lot of things where people don't have access to markets that might not be trading hits and drugs and things like that, but are more benign things that just didn't have, there was some sort of government censorship or there was some other lack of access. And then sort of related to the government side, you have systems that are censored, and of course people aren't, those are things that also can be done on blockchain. But we don't necessarily, we haven't really gotten a lot further than that. I mean, we're building gambling apps. we're leading the charge with the usual players. And I don't think porn has found its way on there, but we definitely have gambling, and we definitely have, what am I looking for? What's the other sin? Gambling, gaming, and advertising, things like that. But what we do have is a new set of primitives, and so my goal here isn't to just sort of lay out like these are the things you can do with the apps, but I'm trying to get into a little bit more fundamentally, like what do apps give you, what do decentralized apps give you that might be worth the costs, and it's really up to your creativity to figure out how do you put these things into something useful. So from just a general perspective, the previous diagram you saw basically, these apps are trying to vacuum data out of users and hoard it off to the sides. Because we're actually asking the user for permission, the user actually has a lot more control, and that really prevents a lot of those effects. And just looking at the way that this has progressed, you can actually think about the money transfer function of Bitcoin as being the original DApp. I mean, it doesn't do much. It's not that interesting. I mean, it is very interesting from a meta perspective, a societal perspective, but from a technical perspective, it's actually not that interesting to just sort of send Bitcoin between two wallets. But that's basically the original decentralized app. And then you started getting some more stuff around where you could program transactions a little bit more. You could apply some conditional logic to when am I going to release these funds and things like that. And now we're with Ethereum, we're getting, and beyond, we're getting deeper into the logic that you can run on these decentralized networks is much more complex, and you can actually build essentially a Turing complete, like a full computer based on these networks. So my point here is just that a lot of things actually technically qualify as decentralized apps, and right now we're just kind of pushing the envelope more and more complex and trying to see where can we go with this stuff. So I want to talk about primitives. So the idea of a primitive is really just what do you get? What do you get for free when you sign up to use the blockchain? And different platforms, different technologies give you different sets of primitives. Blockchain has a few that are actually quite powerful. So there are really three big categories. One is identity, because everybody on the account, everybody, every contract, every refrigerator, whatever it is, everybody gets an account, and that account can hold all sorts of different stuff. It can hold your money, it can hold your data, it can hold your CryptoKitties, it can hold your house if some people have their way. You can put a lot of stuff in that bucket. Transactions are the other one. So we talked about transactions, cross-border transactions, things like that. Well, what blockchain gives you that's a little bit different, or what it gives you out of the box, is actually I'll go into this, but transactions are fundamental. They're a fundamental thing about the way that we've designed blockchains. We've basically created these things. We originated them with Bitcoin precisely so that we could transact, and so transactions have been a core core aspect of this. And of course, cryptography is the other glue that holds a blockchain together. And because it's so fundamental to the way a blockchain works, you expose a lot of cryptographic primitives that developers can use to do things that they might otherwise have a lot of difficulty doing. So everybody here, if you're creating accounts on the chain, will have access to a key. And that key can be used for all sorts of things, where in any other context, it might actually be a pain to get you to sort of deal with these keys, right? So let me go into the identity primitives. So I want to dig in a little bit deeper on what each of those three categories offer. So as I said, everything on a blockchain gets assigned a contract. So it's sort of like, when you get created as a user in an app, like whatever it is, when you create your wallet, you get one of these nonsensical hashes, and that becomes your account. And your account sort of has everything attached to it, and everybody gets one. And the cool thing is that accounts don't have to be humans. Accounts are they don't care. You have an account that's assigned for a smart contract. You have an account that's assigned for your refrigerator. You have an account that's assigned for you. And that's interesting, because we don't always get that for free with other systems. The other one is ownership, of course, which is that the account actually is a bucket that allows it to control all sorts of things. So your refrigerator could have tokens in it, in its account, and you kind of get that for free. Again, I want to be a little careful not to go too ridiculous on the use cases, because the goal is really just to illustrate and let you guys be creative. And then, of course, another one is logging in and dealing with reputation, which is, right now you might have Facebook as your general login for the web, right? You go to a website, log in with Facebook, things like that. But you're trusting Facebook with all of that. And blockchains, the fundamental platform itself, can provide these types of services. And you can also have reputation. And so one of the challenges of blockchain and decentralized systems is the idea of, anonymous systems specifically, is what happens, like how do you have reputation, like how do I know that you're trustworthy, and how can I extend you credit, whether it's actually monetary credit or some sort of social credit to do something. And so you can actually begin to accrue some sort of transaction history or credit as you're on the chain. So transactions, there are a few different ways that transactions are given to you kind of for free on the blockchain. So you have direct transactions. So you have peer-to-peer transactions, which is definitely not trivial. I mean, you might have functionality on your phone where you can send data to people. You can sort of airdrop files and things like that, right? But what this gives you is definitionally, at the very basic level, you have the ability to peer-to-peer transact anything that's in your wallet, any data that you have. It can go peer-to-peer. You don't need my permission. You don't need Facebook's permission. You don't need Apple's permission to do that. And so as a developer, that gives you a lot of freedom to empower your users. Those transactions are also instant, so that's maybe less relevant on the digital side, but on the financial side, that's certainly not the way that the world works right now. You have multi-day settlement, and these for better or worse, sometimes it can be a disadvantage, are instant or more or less instant. Because of negligible fees, you can do microtransactions. So instead of paying Stripe or whoever your processor is 30 cents minimum per transaction, which by definition means you can't have tiny little transactions. This is why people won't take credit card less than $4 or $5 at a coffee shop. It's because they're getting charged 30 cents on that transaction plus 3 cents, plus 3% of the cost, which just cuts out their entire margin. If you don't have to deal with this legacy financial system, if you're just doing a lot of peer-to-peer stuff, you can do much smaller transactions for much smaller fees. You also have conditional transactions, is basically the idea that you can sort of wrap a transaction very, very simply in some sort of basic logic or complex logic that allows you to do things like escrow. And escrow is really important, because how do we, if we're transacting, how do we verify that I'm going to give you at the same time as you give me the whole prisoner swap thing? It makes it quite easy to do that with the primitives that you get on blockchain. So the third category is cryptography. As I said, it's the glue that holds a lot of this together. Two of the cool things that you can do with it, one is you can verify any activity. So if you want to verify that people have done something, whether it's somebody in your supply chain or something along those lines, you can basically checkpoint that on the blockchain, and then in the future you can basically unlock the thing that was kind of locked there, and it's like a little time capsule, and you can say, oh yeah, look, you actually did the thing that you said you were going to do. And on the other side, very similarly, you can also verify that things are in fact fair. that the poker game you're playing actually has a randomness algorithm that's legit and fair. All right, so there's a lot of stuff that those primitives allow you to do. I'm not going to list them all, but if your app needs peer-to-peer transactions, if you need to handle money, if you need to deal with easy verifiability, if you need to escrow a bunch of stuff, these are all questions that say like, oh yeah, maybe blockchain actually does give me some tools that I didn't know that I could use that easily. I wouldn't know what to do with those things. I wouldn't know how to put those things in if I wasn't working with this platform. So next I want to talk about the actual interactions. Like, what's it like to work with a decentralized application? So one of the core tenets, one of the core facets, as I was talking about, is permission. A lot of this requires permission because a lot of what we're doing is asking the user for things. So they control their data, they control their accounts, and all we're doing is just borrowing from them the access rights to change things. So an example is a marketplace. If we're running a decentralized marketplace and you want to transact with somebody else, maybe it's a decentralized exchange, maybe it's a collectibles marketplace or something. Who knows what the future is going to hold? But the marketplace needs to ask you for permission, and you don't actually have to give them your information. You don't have to give them your password. You don't have to give them anything. You basically just allow them. You basically greenlight a specific transaction and say, yes, I allow this transaction to occur. And you don't have to trust them, they don't have to trust you, but it goes through anyways. So the core of all of that is the wallet. And so that's something that's new. That's something that's weird, it's new, it's a pain in the ass for all the users. It's kind of the great strength and the great weakness of all of this. So when I say you get cryptography for free, what I really mean is you have to go through all the trouble of setting up a wallet, and then you get cryptography for free. So we're working on making this easier. But the idea of the wallet is that basically your wallet kind of lists any accounts that you have created, and all an account really is your private key, your cryptographic key that points to the safety deposit box, which lives on the blockchain. So your wallet doesn't store a whole bunch of information. It's just a little teeny tiny thing wrapped in a bunch of cryptography, but it's a little teeny tiny thing, and that's it. All you need is the key. It's literally like a physical key that you use to unlock things. And it's like a key and a signet ring, that you can use to like stamp the wax on the secret message. That's basically all it is. Most wallets, from a technical perspective, both have that key, and they also have to talk to the network. So as we get a little bit deeper into the stack, generally the wallet will do two things, which are kind of separate. One would be accepting transactions on behalf of the user and signing them, so that you as the user sign those transactions. And then that transaction has to find its way onto the blockchain. And so the wallet usually runs a node from the blockchain, or a light node, or there are a few different ways of doing it, but the wallet also sends that transaction down to the blockchain, which then runs the whatever logic needs to be run on the smart contract. All right. So this might be tricky to look at from a distance. We're actually going to see this a little bit more later on, but this is a wallet transaction flow. It's basically a Coinbase trading flow that goes through MetaMask, which is a wallet that lives in the browser. It's a browser extension. And all this is saying is essentially, I want to buy some stuff, and then the wallet pops up and says, hey, do you authorize this buy to go? And then sort of what are the parameters that you put on it? And then it sends back to the Coinbase transaction, which can then proceed once you've been asked for the permission. So the thing about wallets that's kind of cool is it's not just about money. So again, remove the narrow focus on a wallet as holding tokens, or a wallet as holding money, which again is still not really accurate because a wallet itself only holds the key that points to the money that lives on the chain. But that wallet can point to anything, So you can have a crypto collectible, which are, again, we'll go into crypto. I use CryptoKitties a lot because it's probably the most well-known crypto collectible, and we have a flow coming up from that. But you can store anything in your wallet, or it could just be data about your movements. It could be your passport information. It could be literally anything. So what the wallet, the job of the wallet is just to ask permission and to sign things. So anytime that we want to get something unique from that user, we ask them via the wallet. So all I wanted to highlight here is just the two-step process. So this is a diagram from my Ether wallet, which is one of the Ethereum wallets that's available. And the only thing I wanted to highlight was that that wallet both signs your transactions. So once you give permission for the app to do something on your behalf, you've signed it, and then it actually sends those transactions out to the blockchain. And most of this diagram is about the guts of like how is it sending those transactions to the blockchain, and how are those going to be included. So you don't need to worry about the details there. So I wanted to do a quick case study on CryptoKitties. And so I don't know if you've had a chance to play with this. I don't know if you've purchased crypto before. I don't know if you've purchased crypto collectibles before, but this is the way it works right now. So CryptoKitties, if you haven't heard, it's a game where you breed cats. Each cat is completely unique. There's only one cat like it in the entire blockchain. And that cat has a genetic signature that you breed with other cats, and then they make kittens that have a new genetic signature, and everybody's happy. And it has but what it has is, because these are unique, they have some scarcity value. And so if we all believe they have value, then they have value. And so the way the app does this is or basically what the app offers you as a user of the app, aside from holding a bunch of cute little kittens, is you can breed them with other people, and they have a marketplace where you can actually ask people and sort of offer people to breed with them or with their kitties. This is not the Silk Road. Or you can also sell yours just outright. And so what I did with this was I signed up, and I bought a CryptoKitty, which has yet to show up in my wallet, and I'm a little confused what exactly is going on, but luckily that's not relevant. So what I wanted to walk through was just the UI. Just what are the steps? What does it take to interact with one of these decentralized apps? So CryptoKitties lives on the blockchain, but as we were saying, it gets served. So this front end is visited through a normal browser. It looks like a normal web app, like any other web app in the world. And it's actually being served from a normal server, like a normal web app. So nothing special when you go to CryptoKitties.co. So if you click the Start button, that's when immediately we have to start doing some crypto stuff. So I have a browser add-on, the MetaMask add-on, which is my wallet. And so it's kind of a separate process that runs in my browser. And so immediately, the first thing that it does is it pops up my MetaMask window, and it says, sign into MetaMask. So, sign into your wallet, because we're going to have to ask you for stuff. And so I sign into my wallet, and then basically similar to like a sign in from Facebook. It's the same thing. It's would you like to allow CryptoKitties to just connect with your wallet and see your information? Because MetaMask, privacy is important. They're not even going to give your information out to CryptoKitties unless you say, okay, like I'll let CryptoKitties like see who I am, see my public key. And so we click through the UI, we create an account, sign into that account, and then upon signing in, so in order to sign in, I need to, it pops up another MetaMask thing, and it says I need to actually sign something, which is them creating an account on my behalf. So it's more or less me owning something, and so they have to ask my permission to sign it. Once I quote sign that from my wallet, it's okay, cool. Now we're in CryptoKitties. They have a whole flow to it. Get started with CryptoKitties, do the tutorial. Nothing interesting there. Again, this is like any other web app. I've created an account. I'm just working with it normally. But now I want to adopt a kitty. So what I did was I just went to the kitties. There's a list of these kitties. I looked for the cheapest one possible. Because I don't want to spend all my ether on a CryptoKitty for you guys. I love you all, but and so when I click on that, it basically pops up the kitty, and it says, this cat is owned by Nick, and I can buy it right now for 0.0048 0.0048 ether. So I click buy now, gives me to a confirmation screen on the left. And then as soon as I click OK, buy this kitty, we're back to MetaMask. It's got to ask me, it's my wallet again. And CryptoKitties is basically saying, hey wallet, hey Eric in your wallet, like can I execute this transaction on your behalf? And this one's going to cost you money. So what it's asking me is are you willing to pay the gas fee that this is going to cost? And we'll talk about gas in a little bit. And are you willing to pay the cost that you said you're going to pay for your kitty? And so I have to confirm that. And so once I confirm that, now the website reloads, and now suddenly there's a transaction there that's sitting there, and it's waiting for me. And you can actually view the details of it, and I'm sure nobody can read that on the right, but basically that's Etherscan, which is a website that actually examines the blockchain itself for Ethereum. and it looks at the transaction that's going into the blockchain, and it kind of pops it up and gives you all the information you need about that transaction. So what we're looking at there is, okay, the transaction went through, and it's officially on the blockchain that I'm asking this person to buy their CryptoKitty. So he hasn't approved the sale. I don't really know exactly what's supposed to happen. I'm a little bit confused as a user, but this is irrelevant for you guys. I was just checking that the sale hasn't been finalized, so I probably missed something in the tutorial, but irrelevant. So my point in walking through that was just to show the different points, kind of the different high-level things that are happening, and when they had to ask my permission, right? So they had to ask my permission to create the account, and they had to ask my permission when I was spending money, which was real money. So at some point, in theory, I'm going to have a CryptoKitty.
So the fund was transferred before the approval, or?
It was transferred before the approval. So I don't actually know what it's doing behind the scenes right now, because it's sort of I'm in limbo right now. So I think they might be escrowing the fund off to the side and waiting to see if they're going to accept it. And if they don't accept it, it might go back to me. I don't actually know what they're going to do. So what I want to do right now is get a little bit technical. Let's just dig in a little bit more, start exposing a little bit more technical terminology and a little bit more architecture behind what's actually going on. So we'll kind of back up for a second out of the example of CryptoKitties. I'll jump back into that. But so what does it actually take to build a decentralized app? Again, the front end is just a front end. You know, it's the same front end that you're used to building HTML, CSS, and JavaScript. The only thing that's different is that you have to program the JavaScript on that front end to understand how to ask the wallet questions and how to send transactions to the blockchain. You have to, and usually this is going to require some sort of library that the platform you're building on top of is going to give you, or somebody's going to give you, some developer is going to give you this library that sort of translates between vanilla JavaScript and blockchainese. And then of course you have to build a smart contract which lives on the blockchain and actually does the stuff that the browser is trying to get you to do. And then of course you have to deploy the smart contract to the blockchain. So the high-level flows, I want to just try and hone in on conceptual diagrams as much as possible. So this actually shows the flows for two different types of apps. So on the left we have a web app, on the right we have a mobile app. Kind of the point of showing them side by side is that there's really ultimately no difference. The only difference is the web app. You might use a JavaScript library on the mobile app. You might have an SDK that's kind of embedded with the mobile app because you had to download the thing. It's probably written in the same language. And that basically the flow of this is, when a transaction's coming through, it comes through from the app. It has to ask the wallet, and then the wallet figures out how to push it down and talk to the chain. That's really all I want to show here. There's a little bit more in the diagram about how the wallet might find its way to the chain, but I don't think you need to worry too much about that. That might be deeper than we really care about. But if you're interested, I guess I'll explain. So there are generally kind of two options for sending transactions to the chain. So the wallet can either run a node actually itself, in which case it literally is part of the chain in a way. Because again, it's just a whole bunch of nodes around the world, and so one of those nodes might be running in your browser. It might actually not be doing all of the work of the chain. It might be kind of a light node. But the idea is that it's talking to its peers, and it's synced to the network, and it knows what's going on. So that's one way of doing it. The other way is hey, centralization, it's back, is basically hard coding an endpoint that it knows how to reach, which is a trusted node. So you might have heard of Infura. That's effectively a trusted node for the Ethereum network, where they basically said, you know what, if you guys want to send transactions to Ethereum and you don't want to run a node in your browser and you don't want to sync it to the network and you don't want to figure out how that works or use resources or whatever it is, just send it to us and we'll make sure it gets to the network on your behalf. Which, like warning bells, centralization, single points of failure, things like that. But it's the way the world works, right? We're constantly sort of sloshing back and forth from decentralizing to doing something that's easy to decentralizing and doing something that's easy.
This MetaMask is like running as a full node on your browser, or is it like connected?
I don't know what they technically call it. I mean, it's synced to the network, but it could be a rapid sync. So yeah, we can dig into that a little bit after if you want. So I'm the kind of person who has to understand step by step. So maybe you guys are, or maybe you can tune out for 30 seconds. But really walking through the steps of what's happening when a user is doing something on the web page. So again, you can think of the CryptoKitty example. What's happening when I'm actually trying to buy that thing? So the first thing is obviously I'm interacting with a web page and I'm clicking buy. I say do the thing. I say buy the kitty. The second step is that then my front end's JavaScript code is gonna record that I push the button, and it basically has to check for a wallet and say, hey, do you have MetaMask installed? If yes, great. Here's the transaction that we want to get MetaMask to sign, and like call me back when you're done. And so then everything moves over into the wallet. So now it's the wallet's turn. Your app has no idea what's going on now. Your app is just sort of whistling off to the side. And MetaMask is now, or whatever wallet it is that you've chosen, now that's the one that pops up the window for the user and says, hey, we just received this thing that supposedly we're supposed to send back to the chain on your behalf. Is this real? Do you approve it? Whatever. And so once that gets your permission, then it's going to use, as I said, either the trusted node, or it's going to actually already be synced up into the network directly, and it's going to send that transaction that's now signed to the network. And so then the blockchain network, now you're in the blockchain network, and now the transaction gets propagated, it gets included in a block, and then it actually gets run using the smart contract code that you've created, because the transaction is basically pointing to that smart contract, and it runs that smart contract. And then finally, of course, something has to come back. So once all the nodes have achieved consensus, have figured out, hey, this is what the smart contract result should be, we're all in agreement. It's now been whatever, 10 seconds, 14 seconds on Ethereum. Cool, let's send that thing back, and we're good to go. So that's kind of the step-by-step life cycle, and you can kind of see a picture of it. Again, step one is in the user interface. It pushes through your JavaScript code. It goes to the wallet, which then has to ask you questions. That wallet will then send it into the blockchain network, which runs the code on your behalf and sends the response back. So as a developer, what are you going to pay attention to? I mean, you really only have, it depends on your function, either the top two or the top three. If you're more of a designer, you might be focusing more on the third one. But basically, you have to build a smart contract that sits on the blockchain, and you have to build the JavaScript code that knows how to talk to the smart contract up in your app. And yes, it's going to go via the wallet, but I mean, you're the one who has to code the JavaScript, and you're the one who has to code the smart contract. And then, of course, the user interface, everyone has to think about that. So we always want to put that there because, again, this flow is a real pain for users. So again, we're constantly pushing forward and trying to figure out how do we streamline this, how do we remove steps, how do we create defaults and things like that. But the user interface is still super important. The user flow is still super important. Just a quick technical aside, smart contracts can call other smart contracts. So it's not like you have to build this monolithic thing that can't reach out. If you're a developer, you understand that's silly and doesn't make any sense. Smart contracts can talk to other smart contracts, which, if we look at CryptoKitties, CryptoKitties has a whole bunch of smart contracts inside of it. So they actually technically have more, but these are kind of the main ones. There's a pretty good blog post out there where they talk about that. So if you're curious, you could probably Google around and find it. But they essentially have the one big kitty core contract that then calls out to specific contracts that each have specific functions. If you're a developer, you're used to this. This is just modularity. But all I'm trying to say is you can do this in smart contracts. It's not quite as seamless as it would be in the normal developer world, but you can do it. So one contract has all the meta stuff. One contract figures out how do you actually create new kitties. One contract figures out how the auctions work, stuff like that. And so just a few notes on the architecture. So the display logic is actually on the server. So this is something specific for CryptoKitties. It may be true it isn't necessarily a general commentary on decentralization. I'm only really bringing it up just to flag that nothing is absolute. And something like CryptoKitties, it's running on the Ethereum network, but at the same time, there are elements of it that might feel more centralized. And so nothing is absolute here. And so, for instance, what do you actually get? When you own a CryptoKitty, like, what does that even mean? So technically speaking, in one of their contracts, I think it's Kittybase, they have data structures. They have big arrays that basically just record all of the kitties that are out there, and then they just map it to what account number owns it. And so what do you actually own when you own a CryptoKitty? I mean, effectively, what you actually own is its genetic signature, and that's about it. What they own is, and again, this might be a little bit old because this is a lot of this information is from about a year ago, and they were talking about changing it. So this might be a little bit different, but as a case study, it's still useful. You own the genetic signature, but they decide how to display it. So all of those fancy graphics that make the bug eyes and the cute little tongue sticking out and stuff like that, that comes from them. That comes from their server. So technically, they own the rights to those types of things. So it is an interesting commentary on what do you actually own when you own something that's decentralized. So again, another one is, of course, that the website itself is served from some sort of static host, most likely. They could have served it from a torrent network, so that is actually possible. Is you can serve static pages from decentralized sites. You could serve it from potentially IPFS. You could serve it from a BitTorrent network. It might not work out too well because users might not be able to find it on a .com. It's all sorts of interesting issues there. But I just wanted to say again, emphasize that none of this is totally reinventing the wheel. The website had to come from somewhere. The HTML code had to come from somewhere, and it wasn't the blockchain. And
they are hard-coded to use a MetaMask, so I cannot use any other wallet in my browser to access CryptoKitties.
I believe that's what's going on there. Yeah. Again, the code is probably different from when I took a look at some of this stuff, but yeah, it's. I was pretty surprised when I saw that too. And then finally, the code it's not actually open source on GitHub, which is a bit unusual, but there is. I mean, it's on the web. I mean, it exists somewhere, and you can find it if you're curious to poke through it. So last things I wanted to talk about were just a few other considerations, and one of the big ones is gas. Like, what the heck is gas? So the wallet is probably the biggest interaction difference between the blockchain and working with a DApp, a DApp, whatever, and working with a centralized app. But then as a developer, yes, you have to think about the wallet, but in a lot of ways you don't actually have to think too much about the wallet because you just sort of like make your transaction happen and the wallet figures out what to do. But you do have to think about gas. And so the idea of gas is that these networks have to get paid for by somebody. So I mean, you have a whole bunch of nodes that are running the blockchain, so how do they get paid to do the work that they're doing? And they get paid by you giving them a transaction fee whenever they run your transaction on the chain. And so that's gas. And so in Bitcoin is generally one of the simplest overall networks because it really only does one thing. It really only transacts Bitcoin from one address to another, and then it has some simple functionality on top that people have kind of built a lot of stuff on top of. But fundamentally, it's pretty basic. Each block on the chain in Bitcoin can only hold a certain amount of bytes of space. That's how they've decided that they're going to make sure that their blocks don't get so big that it takes forever to send it out to the network and that computers can't hold them and things like that. So in Bitcoin, it probably makes sense intuitively that if you had a gigabyte-sized block, it would take forever to propagate that to the network, and then you'd have an infinite blockchain time, and no one would ever get it. In smart contract platforms like Ethereum, it's kind of the same idea, except instead of space being the fundamental requirement, it tends to be computing time, or the amount of energy, like the amount of cycles that thing is actually using, that run of your smart contract is actually using. And so the idea of gas is that how do we actually account for that? So it's really easy to say, like, how many bytes is this piece of code, the snippet of data that you sent me, which represents a transaction? It's a lot harder to be like, you sent me some code that I'm supposed to run on my machine, but I don't know if this is going to take me 1 unit of time or 100 units of time. And like, how do we even pull that together? But we have to figure it out because otherwise, again, you run into the problem where you might ask each node to run a silly amount of code, and it kind of like slows down everything and gums up the whole system. So the idea is that each block has a limit on gas, and gas is just an accounting measure that represents how much complexity on the computing side does a given operation take. So a simple operation like transferring somebody tokens might be super lightweight, just requires a little bit of gas. Something like writing data to save it to the chain might be much more complex and take a lot more gas. And so the idea is that you as a developer need to be conscious of when you're running your code, how much gas is that code actually requiring to run? Because somebody's going to actually have to pay for that gas. And so the wrinkle here is that, again, on the Bitcoin blockchain, how do you, if there are more transactions that want to be in the block, then there's actually space in the block. The people who are running this block, the nodes on the chain, well, actually the miners technically, but I'm sort of conflating proof of stake and proof of work a little bit, so sorry for that. But if you don't know what I'm talking about, don't worry about it. But basically, the people who are minting these blocks, they need to figure out, well, I don't know, there's 5,000 transactions waiting, and I can only fit 2,000 in this block, roughly. How do I pick which ones? Well, I pick the ones that are going to pay me the most. So every transaction on Bitcoin comes in with an offer price, and it says, hey, like I'm willing to, or a bid, and I'm willing to put this transaction in here for this much Bitcoin, and the other guy is willing to pay this much, and so it's actually pretty easy for the block producer to then say, oh, I'll just take the most expensive ones that are going to pay me the most. It's pretty vanilla. With something like gas, that's basically the same principle. It's like, if there's like 10,000, there's a 10,000 gas thing that wants to get in. There's a 100,000 gas thing that wants to get in. There's a whole bunch of these different sized transactions that are trying to get in. We have to allow them to sort of fight their way in by paying who's going to pay the most. And so that's what Ethereum is doing with gas. So the gas is how much the accounting, on an accounting basis, like how complex that transaction is going to be, and then they actually submit a bid for what they're willing to pay for each unit of gas. So it gets kind of complicated, but like once you get familiar with it, it makes sense. So again, in Bitcoin, you can almost think of it like how many Bitcoin per byte of size am I willing to bid to get into that particular block? Same thing is true with Ethereum. You say how many Ether am I willing to bid for each unit of gas in order to get into the next block? So it's pretty complicated. And so that tends to be a hurdle not just for you, but for the users too, because as you saw in my MetaMask, it was asking me, there's a gas fee sitting there. And the reason for that is that any chain, even though I didn't actually necessarily, even though this transaction wasn't necessarily consummated, even though I didn't necessarily get my kitty, somebody on the blockchain had to run this transaction regardless. Right? And anytime that you're asking these nodes to run something, you have to compensate them, which means you have to pay gas. So something that's fundamental about the blockchain, which is challenging coming from the Web 2 world where things are so low cost that you don't really end up paying for a lot of this stuff, is that you have to pay for every single time you ask people to do work on your behalf. And if you're a developer, you understand how many times in a given flow of an application you're actually asking for compute help and you're asking for compute power. And so every time that we're trying to do something that touches the user that's asking the chain to do something on their behalf, it has to come with a gas cost. And so some apps will assign a default gas cost because, again, remember, the more I'm willing to pay for my gas, the more likely it is to get in the next block. If I'm not willing to pay much at all, it might just sort of sit out there waiting and waiting and waiting and waiting. And so sometimes you actually ask the user for that, and you say, hey, how much are you willing to pay? And the user's like, what the hell is gas? And other times the app will sort of just average, the last few blocks, and it'll just say, I don't know, like you'll probably get in there if you bid this amount, just do it. But
so how is this getting its number, the gas?
So
like by default, or?
I'm not actually sure. I think CryptoKitties might be monitoring the chain and getting an average of the last few blocks and using that as their gas fee. Or they might be outsourcing to a third party that does something similar and then suggesting this as the gas fee that I should be bidding. Because what happens is, I won't go back to the slide, but if you remember the block explorer that I showed where you sort of, the website that tells you all the data about the transaction that hit the chain, like that'll also show off all of this stuff, like how much gas did it, how long did you have to wait until it was actually accepted in the next block and things like that. So yeah, so who should pay for it? Open question, right? Should a user pay for it? That's a real pain. Nobody, frankly, if you're thinking about user experience, the user should never have to do anything because they don't want to do anything. But somebody has to pay for this. We haven't gotten to the point where it's totally abstracted away. And but it can be costly if you're a developer, especially if you write inefficient code. We're kind of back to the days where you had to, in embedded systems, like back in the day when you're managing memory, you had a finite amount of memory on chips and things like that, right? I guess today you still do, but it's kind of a different world when you have to actually think about these things. So again, it's sort of a step back from a development perspective because you're having to think about these very, very detailed technical things. All right, so if you want to dive deeper, things that are a little bit out of scope, data storage. So I mentioned it's pretty expensive to write to the chain. Well, what if you want to save an image? What if, these are normal things that any Web 2 app actually needs to be able to do. And so there are solutions that are out there that are sort of working on this problem of how do you build a decentralized file storage system. So the most common one is IPFS, Interplanetary File System, which is related to the Filecoin token. And that's one thing that you can look into that a lot of developers will hook into. It has its own challenges, its own decentralization issues, which are out of scope. And then naming is another one. Nobody wants to copy paste all of these giant hashes where if you put in the wrong one, then it goes to, you've effectively destroyed whatever it is you thought you were sending. So these are all problems, and so you have projects that are trying to work on how do we solve the naming problem, how do we solve across all of the blockchains, sort of like with domains, the DNS system in domains says, there's only one www.google.com, things like that. Like, how do you do that on the blockchain side? It's not trivial, and there are a lot of projects out there tackling it, but you as a developer are going to interface with these things. So a few things just to kind of close out with on the issues. Open source, so everything is open source here, so get into open source culture if you're interested. Another one is governance is super important. So the CryptoKitties contract, for reference, has basically they have roles hard-coded in there where they say, well, this is the account of the CEO, this is the account of the COO and the CFO, or CTO and CFO. Anyways, some of the executives in their company are hard-coded into the contract, or are basically written into the contract in a way that they can make changes. So, for instance, you can imagine they might want to have the money that the contract has accrued from their transaction cut of running these auctions. Like somebody wants to get paid, right? So you have to figure out where to send that. But what it means is that they've actually written this in that somebody has power to change this contract. Is that centralized, or is it decentralized? Again, the sloshing, right? As a developer, I want to be able to update my contract. Like, what happens if I see a bug and I want to fix it? I want to be able to upgrade my contract. But if I'm the one who can upgrade my contract, doesn't that mean that it's centralized and I'm a single point of failure? Because if somebody has a gun to my head, I could do something nefarious. So things to think about. And governance is a really important issue. It's an important issue on the basic blockchain level, which is where you tend to hear the term used. But it's also an issue on decentralized apps. Like anything that's decentralized, where you have to make changes to it, how do you make those changes? Like, who decides who makes these changes and how? We talked a little bit about decentralization, and then the final thing to go out on is if you need to know something, how do you know, where do you get this information from? Like, if I'm running a sports betting site and I need to know what was the score of the Lakers game, where do we get that? Because if there are 1,000 nodes who are all running this piece of code that are all asking, what was the score of the Lakers game? Does that mean that each one of those is going to send one of 1,000 requests to the API for the ESPN.com or whatever it is that's publishing this score? Or, I mean, that doesn't make any sense. And a lot of them might not, it might not be written in such a way that you can actually make those web requests. Like that's sort of like, the whole idea of these nodes is you're trying not to allow the code to break out because that's a security risk. So how do you do that? How do you find information that's coming in? These are super trivial problems in a centralized world, and it's not trivial at all in a decentralized world. And so we call that the oracle problem. You need to get this source of truth from somewhere, the oracle on the hill. So who is the oracle, and who decides how the oracle gets their information? A very interesting question, and again, one that's out of scope for us today, but well worth thinking about. So that's all I have for today, but I'll stick around for questions. So thanks a lot, you guys.